Hi folks, welcome to another Craig's hack. I've just recently been putting together an entry for an Iron Viz contest, Tableau public. So in this video I'd like to tell you the story of how this Viz came together, what I learned along the way and some of the trickier things that I built into my entry. But before I show you my entry, I'd just like to tell you a bit about the contest itself. So one of the cool things about the Iron Viz contest is it forces you to test drive some of the new features in the new releases. Last year, version 10 for instance, challenged us to develop a mobile version of a Viz, and this year around the new Tableau 10.2 release supports geospatial connection. So you guessed it, the theme for this contest is to connect to a geospatial shapefile and see what we can come up with. So the first thing you have to come up with to put together a Viz is obviously a shapefile. So I had a bit of a hunt around and I found something of interest here. There's a tectonic plates data set including a shapefile. So the first thing you notice how easy it is to bring that shapefile in and visualize it in Tableau. So this shapefile is a pretty simple data set there. It's got some geometry and some plate names. Let's have a look and see what that looks like in Tableau itself. So if we double click on geometry and we just drag plate name in as a label, you see now we have some nifty shapes that appear in Tableau. The second thing you'll notice is how sparse the data is. We haven't really got anything in terms of measures to visualize there. So what we need to do is find some interesting data, something to do with tectonic plates, and blend it in. Well, I was able to get my hands on some earthquake data, courtesy of the US Geological Survey, and that is all data of all earthquakes since 1900 or so. So if we pop them onto a Viz with latitude and longitude, and we put this down at level of detail, what you can quickly see is that the earthquake data does in fact correlate with tectonic plates. So what kind of data do we have about earthquakes? Well, we've got the magnitude and a few other bits and pieces. If we were to just say, for instance, colour the earthquakes by magnitude, scale here, kind of start to see some nice red dots here for the big earthquakes. Let's find out whether the big earthquakes happen in any particular tectonic plates and anything else that we might want to do. But before we do that, we've actually got to create a relationship between our earthquake and tectonic plates in the shapefile. So how will we do that? So let me show you what I did to get a hold of that relationship. So I've got myself a geospatial tool here. I use Alteryx, and what I bring in is all the earthquake data, and if we bring in the shape data here as well in the shapefile, what we can do is do a spatial match. So if we do a spatial match between those two data sources, first thing I have to do is just create a spatial object here for the latitude and longitude of the earthquakes. So we bring that data in here, and we're going to see not where they intersect but where they are within. So where the earthquake is within the file, and what we want to do is we want to output that data to a simple table. Let's just call it quake and plate. We'll just do a CSV file. But before we do that, we really only want to put out a couple of columns. So the only columns I'm really interested in here are the ID column of the earthquake and maybe the plate code. There it is. I might even rename it plate code. Okay, so that'll spit out a nice table there that we can use in our join in Tableau. Well, what I might do while I'm also here is just make that shapefile a little nicer. So some of the things that I can do here are to add in some spatial info to a shapefile to make it a little bit saucier. So what I'm going to add in something like the square kilometers, and I might even add in a centroid X and Y if I need that, use that. So I might just write that out to another shapefile. And we're just going to write that one out to, let's put it in the same spot. New shape dot shape. So let's run that one. Let's see what we get. Before we go and use that shapefile and the joining table in Tableau, why don't we do one last thing here, and we're just going to add a couple of pieces to this flow. So we're just going to add in another shapefile. This one's just going to pick up the ID of the earthquake and the centroid of the earthquake. It'll give us another shape to play with in Tableau. We're going to see what that looks like. So just going to run that. That'll give us an earthquake lat long shape. Let's go back to our Tableau viz. Okay, so there's our earthquake data. Here is our new shape, and there's our quake and plate. So let's drag that one into our data set. That's going to join on earthquake ID equals earthquake ID. And we're going to join our new shape. So this is cool. We just drag that shape file in, and Tableau looks inside it, makes its own guess, and let's just make sure that it got that run right. When it gets there, no, it doesn't quite know what to use, so we're going to have to give it a bit of guidance. We're going to say we're going to join up the plate code to the plate code, and inner join should be fine. And one last piece is we'll actually add in that earthquake lat long shape as well. This one we really want to join on earthquake ID equals earthquake ID. And make sure they got that right. Yep, sure. Alright, so now what we've got is a data source that starts off as SQL Server. It's got a CSV joining to it and two shape files. So let's go and have a look at what that one looks like in our data set. So here we are back at our viz with our new improved earthquake dataset, and now you can see we have the new shapes including a plate name. So why don't we go ahead and use that. So there's the color, and we'll just verify our theory that the earthquakes are correlating with plates, and there we go. You can see those in full color. Even Easter Island. There we go. So what else can we do now that we have both lats and longs of the earthquakes and the shape files? Let me show you the new sheet. So we've got this object here called geometry, which we get from our earthquake file, but we've also got one here from our shape file, two different ones. So if we use the shape file one and we grab our plate name, let's put that down at detail, we can see now that we've got individual plates. And maybe we could color those by so the maximum magnitude, find out where the nastiest plates are. We go ahead and make that orange and blue, pass it around. So there we go, we're seeing that South America and North America, maybe a couple of plates over here, got some big earthquakes. But one of the things that we can now do that my friend Alan Eldridge, the last data blender, put me onto recently with the blog that I read just the other day, is that now that we have two geometries here, we're using latitude and longitude generated rather than the ones from the database. So what we can actually do is do a dual axis without losing our map. So let's just grab a dual axis there, and this time we're going to, instead of using that geometry object from our shape file for plates, we're going to use the one from our earthquakes. bring in so the ID and the place into our detail. And notice that we've got two maps. So why don't we go ahead and make that map layer dark. It works a bit better on this one. And we're going to make that a dual axis. So now we're able to have plate shape objects with all the little earthquakes that happen on top of the shapes, right down to knowing where they are and what the individual magnitudes are. Pretty cool, hey? Okay, so now we've got a pretty cool data set. So how next to build in something that will give me the edge in an Iron Viz contest? So past Iron Viz winners have had something quirky, something just a little bit different. So what was I going to use? So it came to me what my plan was when I was mucking around with the data and I started filtering out some of the shapes. And I thought, wow, that's starting to look like a jigsaw puzzle. So I used that to my advantage. I parameterized my 7 of my plates and turned this into a jigsaw puzzle. So the idea is that you use the selectors above, these are parameters, to match the orange numbers below. And if I just show you a giveaway, this one, Africa is 7, and that one disappears, and you see Africa appear below. So once you finish the other 6, then you get to claim your prize. So without spoiling that, I'm just going to pause it and get to the end so you can see what happens. So look, before I do the last piece of the puzzle and show you what the prize is, I just want to show you a couple of things here. So we've got a little hover over the top of an eye to give people a bit of context to what this is all about. And notice over here we've got all these funny objects over here. What I wanted to do is not distract people with filter controls until they get to the next piece. So that you'll find that each of these little pieces here are actually empty vizzes that cover up text, take people's attention away from those. So let's just go and finish that last piece of the puzzle. And you'll notice that text now flicks over to a different bit of text. All of those empty boxes now have data in them, and we now have a completely different viz appearing in our vertical window. Did all that through table calculations and window sums based upon the parameter selections. So by all means download and unpack that, figure out how I did it. It's quite tricky. And the other thing you'll notice now is we get those plates are back, but with a bit more data. So we now have all of the information at our disposal, and we can colour those plates by various different measures. But I just didn't want it to be a plate with a bit of data in, so I'd like to tell a story as well. So this is the story of how scientists developed tectonic theory, and they use instruments last century to confirm that theory. So I wanted to almost make this possible to be a classroom tool. So the object is that once you select a plate from this viz, you get to explore all the earthquakes and figure out that correlation for yourselves. These marks here are actually point marks. I like the nice curvy bits on the edge. I find that tells a good story without having to do an actual story dashboard. So let's go and have a look at the plates that have got lots of big earthquakes over magnitude 8. And this one up here near Japan has had 13 big earthquakes since 1900. So what I'm going to do is click on those, and now we see that that viz is actually self-filtered back to itself. So that's another little trick that's worthy of finding out how I did that. And now we see down here another viz with all of the earthquakes. So we can quickly see that there's been some nice big earthquakes off the coast of Russia and Japan, and causing tsunamis and 10,000 deaths back in 50. And you'll notice I've actually got a richer data source in there, so I've got number of deaths and damage and so on. So blended in yet another data source. into my flow. And here we go. This is the big earthquake that we got from off the coast of Japan in 2011, 6 years ago. So one of the things that I also wanted to do was allow people to go and find out more if they wanted to. So let's find out a bit more about this earthquake back in 52. So what I'm going to do is allow people to click on that, opens up a Google search window, and with any luck we can see the earthquake that occurred in 1952. We can go in and read up about it, find out a bit more. So last but not least, I know that a lot of people are going to be looking at the entries to this Iron Viz through Twitter feeds and so on, and it's going to open up on their mobile, and there's nothing worse than opening up a viz like this on a mobile. All you just see is a tiny slice over to the edge. So I've actually built in a mobile viz, squished it all up and got it in there. So let's just have a quick sneak peek of what that one looks like. So there you go. So we can actually get a mobile friendly version of that one up and running. And there we go. Hope you enjoy. And thanks for watching.